So you have to do the odds on the front of this because I am oh so nice. And then you have to do all the graphs on the back. Now there's more than one way to figure out if functions are inverses of each other. For this one, we could just find the inverse function of g and see if that's actually what f is equal to. That's totally fine. And that's actually the easiest way to do this. But remember, if you compose two functions and they cancel each other out, then they're inverses. So if you wanted to, we could do g of f of x, or we could try f of g of x. And if they cancel each other out, in the end, we're just left with x. It doesn't matter which order you do, then that means that they were inverses of each other. But personally, I think that's a little bit of too much work. Let's just actually find the inverse of g. So here we have y is equal to 4 minus 3 halves x. And we want to switch my x and y and solve for y. So 4 minus 3 halves y. I'll add my y and subtract my x. So this is 3 halves y is equal to negative x plus 4. And then I need to multiply both sides by 2/3 or divide by 3 halves to get y by itself. So I get 2/3 negative x plus 4. And if you look, that is not what I got for f. Okay, so note they are not inverses of each other. For number 3, it doesn't matter which one you pick, all right? So for number 1, I picked the top function, but I could pick the bottom function. All right, let's find the inverse of this. So this is y equals 4n plus 16. I need to switch my x and y, but in this case, I'm using n and y. So now I'm going to have n is equal to 4y plus 16. I'll subtract 16. And then I will divide both sides by 4. N minus 16 over 4 is equal to y. And these do match, okay? N minus 16 and negative 16 plus n are the same thing. They just swap. All right, but in both, my 16s are negative and my n's are positive. So yes, these are inverse functions. All right, let me erase this so I can move down. Oops. There we go. Number 5, again, it does not matter which one you do. Personally, I think g looks easier, so I'll find the inverse of that. Y is equal to 3 plus n cubed. Switch my n and my y, so n is equal to 3 plus y cubed. Subtract 3. Now this is y cubed, so to undo a cube, you take the cube root, or raise it to the 1/3 power. It means the same thing. So I have the cube root of n minus 3 is equal to y. That is my inverse function. Okay, this is g inverse of n. And that is definitely not what f of n is. So no, these are not inverse functions of each other. For this, number 7, doesn't matter. Both of them have fractions, so both of them might be a little messy. I'll just pick h because I can. So this is y is equal to negative 1 over x plus 3. I need to switch my x and my y. So x is equal to negative 1 over y plus 3. Okay? Think of it as this is a fractional equation. Equation, we want to eliminate the denominators. Right now, my y, which is what I want, is stuck in a denominator, so I need to get it out. So I'll multiply both sides by y plus 3. So now I have x times y plus 3 is equal to negative 1. Don't distribute the x. Okay, right now we have x on the outside of parentheses. Let's just divide both sides by x, and we've got it moved over. Y plus 3 equals negative 1 over x. And then last but not least, subtract over. Y is equal to negative 1 over x minus 3. So that's h inverse, which is definitely not what f is. So no, these are not inverses either. Erase this stuff. For 9 and 11, we just had to find the inverse function, so this switching x and y, just like we've been doing. Here, I've got y is equal to the cube root of x minus 3. We can switch our x and y. I need to add 3 over, so I get x plus 3 is equal to the cube root of y. And to undo a cube root, you cube. So now I have x plus 3. The quantity x plus 3 to the third power is equal to y, or a inverse. Okay? And we will do the same thing for 11. I have y is equal to 2x cubed plus 3. I need to switch my x and y. I need to subtract 3 first. And before you deal with the cube, you need to get rid of the 2. So we'll divide both sides by 2. So I have x minus 3 over 2 equal to y cubed. And now I can take care of my exponent. And to undo a cube, you take the cube root, or the 1/3 power. It means the same thing. So I have the cube root of x minus 3 over 2, which is equal to y, which is my inverse function. Alrighty. And because I am so nice, you did not have to do 13 or 15, but you did have to do the graphs. Now I'm going to cheat a little because this worksheet came with an answer key, and it already has the graphs on it. Okay? Now, for 17, it shouldn't have been too hard because these were lines. You can put them into your calculator. Okay? And you did have to go through the motions to find the inverse function. So you switch your x and your y, and that's what you should get when you solve for y. Now for 18 is a little complicated, and I would highly suggest that you put this into your calculator. Okay, but looking at this, we should realize that if we put x equal to 1 into g, we are going to get 1 minus 1 in our denominator, which will give us an undefined fraction. So we cannot have anything happening for g of x at x is equal to 1. So if you look at this graph right here, and I'll outline it in purple, this one right here, this is our g of x, okay? Because it's getting really, really close to 1, but it's not actually touching 1. So this one right here is my part of my original g in purple. Okay, and you should have noticed this in your calculator. You got something that had something on one side and something on the other side. This is what we call a hyperbola. Or a hyperbole. Hyperbole is English. Hyperbola. Okay, and if you look at our graph, we also have to have something in the negative. Now, if we look at this, and we can, kind of pick a test point. Let's say I put x is equal to negative 1 in this. Well, I'm going to have 1, negative 1 minus 1. So this is 1 over negative 2. So the point negative 1 half has to go through this. So negative 1 half. Here's negative 1, and I'm down here at negative 1 half. So this one right here is also part of g. And that makes sense because this is also getting closer and closer to 1, to this vertical asymptote. Right, here's my vertical asymptote. Right here at x equals 1, because that would give me an undefined fraction. If we go ahead and solve for our inverse function, we do it the same way that we've been doing it. We switch our x and our y. And we need to solve for y. You need to get y out of the denominator. So multiply both sides by y minus 1. So now we've got x times y minus 1 equals 1. Just like before, don't distribute. Just divide both sides by x. And then add 1. Alright, so this is your inverse function. If you put that in your calculator, you are going to get another hyperbola, but it's going to look slightly skewed. All right, and use your table to pick some very nice points that are going to be on this. All right, and so here is G inverse X. Sorry, I cheated a little, but it's hard to draw things on a smartboard. So I'll erase this. Alright, if you need help plugging that stuff in your calculator, please come in. I will help. 19, we got a cubic. Alright, this is very similar to this might be exactly to the one that we did in class. Okay, and actually this is the one that we did in class. So I'm not even going to go over that one. For 20, if you want to, you can break this up into two baby fractions with a denominator of 3. So this is like negative 1x over 3 minus 5/3. So this means that you have to have a line that has a y-intercept of negative 5/3 and a slope of negative 1/3. That's kind of messy to graph. That's a weird intercept. So again, put it in your calculator, get some nice points, and then you'll find your inverse, and this is what your graph should look like. And boom, baby, done with this homework.